Hello friends, how are you? In previous classes we were discussing about the periodicity of characters, and in previous classes we discussed about the periodicity of atomic structure, that atomic size, or we can say that atomic radius, effective nuclear charge, and after that ionization enthalpy, and then electron gain enthalpy, and then valency. Okay, now in today's class I am starting electronegativity. Electronegativity, got it? The question firstly about that, what is electronegativity? To understand it, let me consider one more example of molecule. That is, suppose there are two atoms A and B, and they form a covalent bond. They form a covalent bond, and you know that in a single covalent bond, both of atoms, that means A and B, share one electrons, which are bonding electrons. These are bonding electrons. Okay, covalent bond electrons or bonding electrons. The tendency, the both atoms have tendency to attract the these bonding electrons, because both atoms have nucleus, and you know that in nucleus there is positive charge, that is proton, and proton will attract the electrons, that is negative charge. So both atoms have tendency to attract these bonding electrons. This tendency this tendency to attract bonding electrons of covalent bond is known as electronegativity. Is known as electronegativity. Got it? Now, if we consider its now, let me move its definition. The tendency of an atom to attract bonding electrons of covalently bond formed between two different atoms is known as electronegativity. It is known as electronegativity. Got it? Now, let me consider its periodicity. That means in a period which kind of changes appear. To describe it, let me take more example. That is one atom, and that is another atom, which are sharing the electrons. These are shared electrons. Suppose that is A and that is B. A is smaller and B is large. Okay. These bonding electrons will attract strongly by A. Why? Because A is smaller. Since A is smaller, so its effective nuclear charge is more than B. And if effective nuclear charge is more, then the bonding electrons will attract more strongly or with greater forces, because these electrons are close enough to the nucleus of A. Since A is small sized, so these bonding electrons are closer to the nucleus of A, so they will experience more attraction forces, effective nuclear charge. Therefore, they will experience more attraction force or effective nuclear charge. Got it? That means we can say that atoms of small sized should have more electronegativity. Okay. Now, if we consider the periodicity, then we can say that we know that when we move in a period, when we move in a period, atomic size decreases. Atomic size decreases and effective nuclear charge increases. Atomic size decreases when we move in a period. Atomic size decreases in electronegativity sorry, effective nuclear charge increases. Hence, the electrons will experience more force, or we can say that atoms will have more tendency to attract the bonding electrons. So we can say that the electronegativity of these atoms will greater. Okay, I am again repeating. In a period, in a period, atomic size decreases and effective nuclear charge increases. Atomic size decreases and effective nuclear charge increases. So the electronegativity increases in the period. Got it? If we consider the group, then as you know, when we move down in a group, when we're moving in a group, that means when we move downside in a group, the atomic size increases and effective nuclear charge decreases. The atomic size increases and effective nuclear charge decreases, and because of that the electronegativity decreases. So in simple word, we can say that in period electronegativity increase, in group it is decrease. Got it? Fluorine, that is halogen, which is placed on the 17th group, is most electronegative element. It is most electronegative element. That one thing that may be possible in come in your mind, that is there is 18th group also, then why that is 17th group has maximum? Because 18th group elements are noble gases. These are noble gases, and noble gases, they do not have tendency to attract electrons because they are already satisfied with their valency. Their octet is filled, so they do not have any tendency to make a chemical bond. If they do not make chemical bond generally, then electronegativity, which is power of bonding, attract the bonding electrons, will also zero. Got it? So the noble gases have zero electronegativity. Clear? Alkalis of the first group have least electronegativity. Got it? Because they are in the first group, and you know that if there is increasing, that means there is less value. Okay, now consider the next topic, that is metallic and non-metallic properties. Metallic and non-metallic properties. Got it? The first, let we discuss about the metallic and non-metallic. What is the mean of metallic and non-metallic properties? An atom, if have tendency to lose electrons, if an atom has tendency to lose electron, and because of the lose electron it will form cation. This tendency of element to lose electron or donate electron and make cation is called metallic properties. Is called metallic properties, and these elements are known as metals. These are known as metals. Which one? Who have tendency to lose electron, who have tendency to lose electron and make cation. These are called metals, and this tendency is called metallic properties. Got it? If we consider the non-metal, then we can say that the elements, some of the elements have tendency to gain electrons and form anions. And form anions. This tendency of gain electron and make anion is called non-metallic properties, and such elements are called non-metals. I am again repeating, the tendency of element to lose electron and make cation is called metallic property, and such elements are called metals, while the tendency to gain electron, to gain electron and make anion is called non-metallic properties. It's called non-metallic properties. Got it? Now, let we consider the periodicity. Firstly, we discussed about the periodicity of metallic properties or metallic characters. Okay? To understand it, there are three factors which affecting it. First one is atomic size. Suppose these are two atoms. One is smaller and one is larger. We have to remove that electron, outermost shell, from which it is easier. Definitely it will from larger atom, because the larger atom have less attraction forces, because as we discussed earlier, when the size increases, the effective nuclear charge decreases. Got it? Clear? So removal of electron from larger atom will be easier, while the removal of electron from smaller atom will be difficult. First thing, that is atomic size. Second, effective nuclear charge. As you know that when the size increases, the effective nuclear charge decreases. Got it? Third, which the factor which affecting the metallic properties, that is ionization enthalpy. If it is less, then the removal of electron or losing the electron will be easier. Got it? Because if that is less energy is required, so the atom can easily donate electron. Now, in a period, atomic size decreases and effective nuclear charge increases. Atomic size decreases and effective nuclear charge increases, and because of that, ionization enthalpy also increases. On the combining effect of all of these, the tendency of lose electron will decrease. The tendency of lose electron decrease when we move in a sorry, when we move in a period. And if there is decrease in tendency of donate electron or lose electron, that means metallic properties decreases. It means metallic properties decreases. So we can say that in a period, metallic properties decreases. If we consider the group, then atomic size increases and effective nuclear charge decreases. It results decrease in ionization enthalpy. It results decrease in ionization enthalpy. Hence, the removal of electron, or we can say that losing electron and make cation, this tendency increases. Means metallic properties increases. So in group, metallic properties increases. Got it? Now let me read it. On moving in a period, atomic size decreases and effective nuclear charge increases. Hence, ionization enthalpy increases. So, the formation of cation or tendency to lose electrons decreases in period. Okay? It means metallic properties decreases in a period. Got it? If we consider the group, on moving in a group, atomic size increases and effective nuclear charge decreases. Atomic size increases and effective nuclear charge decreases. So the value of ionization enthalpy, decreases. Hence, the tendency of lose electron and make cation increases. It means metallic properties increases in a group. Clear? Now, let me move to the Second one, that is property of non-metallic, periodicity of non-metallic properties. That are, these properties are just opposite of metallic properties. Clear? When we move in a period, when we move in a period, then atomic size decreases and effective nuclear charge increases. Because of that, the electron gain enthalpy delta EGH will also increase. And increase in delta EGH indicates that the tendency of gain electron, the tendency of gain electron and make anion increases. Clear? So we can say that in a period, atomic size decreases and effective nuclear charge increases. So electron gain enthalpy also increase, which increase the tendency of gain electron and make anion. It means non-metallic properties increase in a period. In group, atomic size atomic size increases and effective nuclear charge decreases. Hence, delta EGH, the value of delta EGH is decreases. This decrease in delta EGH indicates that the tendency of gain electron and make anion decrease in group. Decrease in group. Got it? So, in period, non-metallic properties increases, and in group, non-metallic properties decreases. Got it? Now, some facts about electronegativity. The one question should comes in our mind, that why the semi-metal or metalloids are present in the zigzag pattern. It is because as we move in a period, metallic properties decreases and non-metallic properties increases. While when we move in a group, the metallic properties increases and non-metallic properties decreases. Because of the combining effect of them, semi-metals or metalloids are found in the zigzag pattern. Clear? Now, the elements of the left side of the periodic table are rich in metallic properties. That means the left side elements are metallic, while the elements of the right side of the periodic table are non-metallic. And the metal and non-metals are separated by semi-metals, by semi-metal or semi-metalloids. They are present between them in a zigzag pattern. Clear? The semi-metals are these: boron, silicon, germanium, antimony. Okay, these are semi-metals. To memorize them, a simple line we can use, that बाइक से गए आसाम सब तेरे पीछे. And one thing, let me clear you, that is a very important question for exam, because the one question which is common in our exam, that is, there are various elements given by examiner and asked to separate semi-metals. So that line, if you memorize that line, then you can easily achieve that question. Okay. Now, one more fact, that is, alkali metals of the first group, if we are considering group, then alkali metals of the first group are most electropositive or metallic, because they have highest tendency to lose electron and make cation. So they are most electronegative, while the halogens, electronegative or metallic, okay, while the halogens of the 17th group are most, that was, sorry for that, that was not most, that is least electropositive. Sorry, that is electropositive, that's okay. that is electronegative. Sorry for that. I'm again repeating. Alkali metals of the first group are most electropositive. That means they have highest tendency to make cations, while halogens of the 17th group are most electronegative or non-metallic because they have highest tendency to gain electrons. Clear? If we consider the elements, then cesium is most electropositive, that means most metallic, while the fluorine, it is most electronegative or non-metallic property. Got it? About the metal and non-metal, one more point which comes, that is nature of oxides. In the chapter 5th we discussed that metallic oxides are basic in nature while non-metallic oxides are acidic in nature. Now in a periodic table, how their nature of oxides changes. As you know that in periodic table, the left hand sides that are metals while the right hand side that are non-metals. So there is nature is basic and there is acidic. Clear? As we move down, metallic properties increases and non-metallic properties decreases. As we move down, that means we move in downside of the periodic table, then metallic properties increases and non-metallic properties decreases. It results the nature of oxide here increase from basic to more basic, and here acidic to basic. Here acidic to basic. Got it? Clear? Now let me move our next topic. Here the periodicity completed of element of the properties. The one topic, atomic radius or atomic size, we discussed earlier, but there are some points related about that. So I'm considering here, because if we consider there, then our topic, that is periodicity, will disturb. So I separated from there, and now discussing about it. Atomic radius or atomic size. Atomic size is represented by atomic radius. As we already discussed that atom is a spherical structure, so its radius used to refer is atomic size. What is atomic radius? The distance between the nucleus and outermost shell. The distance between nucleus and outermost shell of gaseous isolated atom. Gaseous isolated atom is known as atomic radius. Clear? The measurement of atomic radius or size is a very difficult task. Is a very difficult task for an atom, because except noble gases, except noble gases, none of the other atom are found in the form of gaseous isolated. That means they, except noble gases, no other element found in the isolated or isolated form. They found in the form of molecule. They found in the form of molecule. So finding an isolated atom is very difficult. Okay, that's why we use different forms to describe about the atomic radius. Clear? Here few of them which are in our syllabus, that is covalent radius, van der Waals radius, metallic radius. Okay, these three we will use to describe the atomic radius. Okay, now the first question comes in our mind, that is what is covalent radius? What is covalent radius? Two similar atoms like the H2, O2, N2, when are covalently bonded, when covalently bonded. Then the half of the distance between these covalently bonded nuclei is known as covalent radius. It is called covalent radius. Got it? I'm again repeating. Half of the distance between two nuclei of covalently bonded similar atoms is called covalent radius. Clear? The distance between the two nuclei which are covalently bonded is called bond length. It is called bond length. Okay? So its half is also equals to the covalent radius. So we can say that the half of the bond length of covalently bonded similar atoms is called covalent radius. Got it? Now let me consider the second one, that is van der Waals radius. Firstly, you should know about the van der Waals forces. What is the van der Waals forces? These are very weak attraction forces. These are very weak attraction forces which are found between the atoms of different molecules. Weak attraction forces which are found between the atoms of different molecules. Let me clear you that it is not a chemical bond. So there is no electron sharing, gain, lose, etc. There is just attraction between the two atoms. So we can say that these atoms of molecules are just attracted but not chemically bonded. They are just attracted but not chemically bonded, and because of the attraction they are close enough. Okay, clear? The distance between, now let me discuss about definition. The distance, the half of the distance between atoms of two close non-bonded molecules. These two atoms of non-bonded, chemically non-bonded molecules, and their distance, its half, is known as van der Waals radius. The first definition is half of the distance between the atoms of two close non-bonded molecules of the same substance is called van der Waals radius. Again repeating, that is distance, half of the distance between the atoms of two close non-bonded molecules is known as van der Waals radius. Or one more thing we can use, that the half of the distance between two atoms which are attracted or close enough by van der Waals forces. These two are attracted by van der Waals forces. So the half of the distance between the two atoms, nuclei of two atoms, is known as van der Waals radius. Clear? That is molecule. These are covalently bonded. So the distance between the two nuclei, bond length, and its half is covalent radius. Similarly here, these are covalent radius, and these two atoms which are attracted by van der Waals force, this distance half, that is known as van der Waals radius. It is observed that van der Waals radius is greater than covalent radius. It is greater than covalent radius. It is because if we compare the van der Waals forces and covalent bond, then covalent bond is much stronger than van der Waals forces. So these atoms of molecules which are covalently bonded will close enough. The atoms of covalently bonded molecules are close enough. Therefore their distance will be shorter. While here there is just attraction force. So the atoms are far enough rather than covalently bonded atoms. These are far enough, so their distance will be more. Got it? Now the next one is metallic radius. Metallic radius. Got it? To understand it, firstly discussed about the crystal lattice. That is a solid form in which the atoms of metals are closely packed. Are closely packed. For example, that is a cuboidal crystal. Here, that is one atom, and here, that is one atom, and that is another atom. Similarly, that is one atom, and that is another atom. Clear? So atoms are arranged in the crystal lattice, definite pattern. The half of the distance, the this distance, it's half of the distance of the nuclei of two nearby atoms which are present in the crystal lattice. Which are present in the crystal lattice. I'm again repeating. Suppose that is a cuboidal crystal in which the atoms are found. Okay, if we consider that it is like this. That is one atom, and that is another atom. These are present in crystal lattice. That half of the distance between the nuclei of two nearby atoms which are present in the crystal lattice of metals is known as metallic radius. It is called metallic radius. Got it? Now, there is one more radius in our syllabus, but this radius is not used for describe the atomic radius. It is a different thing. That is Ionic radius. The simple definition is the radius of an ion is called ionic radius, or we can say that the distance between the radius of an ion is called ionic radius, or we can say that the distance between nucleus and outermost shell of an ion is called ionic radius. Since there is two type of ions, so that is two radius. First is cationic radius, that is radius of cation. Second is anionic radius, that is radius of anion. Now there is two question which is very important for our exam. First one is very important. Why cation is always smaller than respective neutral atom? Why cation is always smaller than respective neutral atom? In the formation of cation, one or more electron is removed. One or more electron is removed from the outermost shell. It results increase in effective nuclear charge on remaining electrons, because there is removal of electron but the number of protons are same, and you know that protons apply attraction force on the electrons of outermost shell. So we can say that the removal of electron from outermost shell increase effective nuclear charge on remaining electrons. So they pull closer to the nucleus because of the greater forces. They will close enough. They will comes close. They will comes close, or we can say that they pull close to the nucleus. Hence, atomic radius or size is smaller, becomes smaller, or is smaller than respective neutral atom. Got it? Similarly, why anion is larger than respective neutral atom? In the formation of anion, electron is added, and because of the addition of electron, effective nuclear charge will decrease. Suppose there are 6 electron and 6 proton, and we add 2 more electrons. First condition is 6 proton 6 electron, and second condition is 6 proton 8 electron. So definitely there will be decrease in effective nuclear charge. And when the effective nuclear charge decreases, the electrons of outermost shell, the electrons of outermost shell, or we simply say that outermost shell spread with more distance, because there is because the attraction force decreases, so they can spread at more distance. Hence the size of anion becomes larger. Got it? Now this chapter is finished. In next class we will discuss our next chapter. Hope you like it. Thank you.